Hi, so my name is Patrick Brown, and I am a climate scientist and head of climate analytics at Interactive Brokers. I'm also a senior fellow at the Breakthrough Institute and an adjunct faculty member at Johns Hopkins University in their Energy Policy and Climate program. And I'm putting on here that I used to be a fact checker for Climate Feedback, which was the official fact checking source for Facebook for a while. And so they used that to upgrade or downgrade various pieces of information on climate on the internet. So I have some firsthand experience in this fact check space. And so this will be a two-part talk. And the first part is called What Can Science Say on Climate and Climate Policies? Navigating the space between facts and opinions. And I will basically juxtapose my eventual position with what has become a very prominent view in terms of answering this question, and that is essentially that the science fully dictates policy. And so there's maybe no more better encapsulation than this quote from John Kerry, former U.S. climate chief, in an interview with The Guardian, where he says, nothing that we are doing, nothing that President Biden has sought to do, has any political motivation or ideological rationale. It's entirely a reaction to science, to the mathematics and physics that explain what is happening to the climate. So basically saying that, the science just, fully dictates, what the policy should be. Now, John Kerry is a politician, but this basic sentiment is really expressed at the highest levels of institutional science. So just a couple examples of that. So this is editor-in-chief of Science publishing in the journal Science a very impassioned defense of the global climate policy, the 2-degree temperature target. So, really giving the idea that, the institution of the journal Science fully embraces a given policy, and that's essentially dictated by the underlying science. That's the message given when the editor-in-chief is endorsing policies. And similarly, our other most prestigious, most high-impact journal, Nature, has officially endorsed in the past 2 U.S. presidential elections. So endorsed Joe Biden in 2020 and endorsed Kamala Harris in 2024. And if you read these, the reasons for endorsement include climate policies. So as a scientific institution, when they're endorsing policies and politicians, they're basically saying, the science says that these are the correct policies. And, Nature got some pushback for that, but current editor-in-chief of Science, by the way, Marcia McNutt is now the president of the National Academy of Sciences, but current editor-in-chief of the journal Science supported the idea that Nature and Science should go all the way to endorsing policies and politicians. And he says that if they don't do that, this gives people permission to say things like climate change may be real, but I don't think we should have government regulation to deal with it, which is unacceptable. So, kind of pretty authoritarian view from a scientist, or at the very least a view that, scientific authority really goes a long way in terms of dictating policies. And this sentiment is very much expressed in media coverage of climate and climate policies. So these are 4 news articles on a recent Conference of Parties discussing the 1.5 degree temperature target. And you see this phrase, scientists say, basically expressing that scientists say that this is the policy that we need to implement. Again, giving the impression that the science essentially fully dictates policy. So my thesis here, my claim here, is that what we're seeing here is actually political opinions. And the political opinions of certain selected people or groups who claim the title of scientists are not actually the same thing as scientific facts. And so there's a conflation there. And so then a key challenge for fact checkers or for decision makers or for society as a whole is essentially distinguishing scientific facts from political opinions. And unfortunately, often political opinions masquerading as scientific facts. So there's a couple tools that I'm going to talk about for addressing this problem of distinguishing scientific facts from political opinions masquerading as scientific facts. And I'm going to pull these from an essay written by 2 scholars of science and its relationship with society, Steve Rayner and Daniel Sarowitz. And this essay is called Policymaking in the Post-Truth World: On the Limits of Science and the Rise of Inappropriate Expertise. And so they talk about a few dimensions of how to judge expertise. And one of those they talk about is how feedback rich are the trials that the experts conduct, which I'm going to kind of reframe and rephrase into how testable is the relevant real world conclusion. And they also talk about how high stakes outcomes are, which I'm going to reframe and rephrase into how strong is the pull towards a preferred conclusion. So basically, the higher the stakes, the more susceptible things are to motivated cognition and motivated reasoning. And so I think these two questions are very helpful for evaluating scientific claims and distinguishing between opinions and facts. And they don't do this in the essay, but I find it useful to kind of put this in a two-dimensional space. So on the x-axis, I'll put how testable is the real-world conclusion, where on the right side we have that it's very testable. It's amenable to numerous empirical trials or hypothesis tests. And on the left side, we have that it's not very testable. Empirical testability is low. And in those cases, claims are often made on metrics that are removed by several degrees from real world outcomes. And oftentimes involve abstraction and layers of models. So fuzzier on the left side. And then on the vertical axis, I'll put how strong is the pull towards a preferred conclusion, basically susceptibility to motivated cognition, where on the top, I'll put there's not a very strong pull. That comes about because broad ramifications of the conclusions are small. Where on the bottom, I'll say there is a strong pull, and that would be because there's major personal, either social or professional, or major broader sociopolitical ramifications and or moral or ethical or value-laden themes. So with these two dimensions, we can kind of partition the diagram into 4 quadrants. So in the upper right, that's where things are very testable and the pull towards a preferred conclusion is not strong. That's where claims are reliably trustworthy and uncontroversial, but unfortunately relatively inconsequential. Quadrant 2, where claims are not very testable, but there's also no broader ramifications of them, claims can be contestable, but controversy remains academic. Down in quadrant 3, where claims are relatively testable, but there's still strong susceptibility to motivated cognition, you have, foundational claims can be relatively trustworthy, but you still get a lot of controversy. And a lot of times that controversy just kind of arises from different frameworks, implicitly often emphasizing different values or essentially having, just different moral frameworks. And then in the bottom left, it's quadrant 4, that's where claims are not very testable, and there's a very strong pull for preferred conclusions depending on who you are. And that's where claims are basically reliably controversial, contestable, and difficult to adjudicate. So kind of a mess down here. So just some examples of all 3 of these. So in quadrant 1, you basically have the kind of quintessential scientific experiments that you learn about and then conduct in high school. So something like dissolving salt in water lowers its freezing point. You can test that very readily, and no one has any preferred conclusion. Quadrant 2 might be some type of academic scientific controversy like string theory, the claim that there are extra curled up spatial dimensions. Not very easy to test, but doesn't really have broader societal ramifications. And so outside of the domain, people don't really care. The bottom right, quadrant 3, is kind of the inverse of that, where people care a lot, but it's a little bit easier to test. Claim might be raising the minimum wage helps poor people. And here I'm saying, testability is relatively high because you can kind of look at different policies across time and across space. But things get complicated with the word helps, and different frameworks will define helps differently and looking at different timescales. So for example, you could have an increase in the minimum wage increases lower tercile wages in the short term, but another economist might come along and say, yeah, but a minimum wage stifles economic growth in the long term, and so it actually hurts society as a whole, including poor people. And so controversies come about from kind of different framings of the question. And in quadrant 4, I have something like society should respond to a deadly pandemic by shutting down schools for a year. So I'm kind of imagining this, especially before the COVID pandemic, that's not very testable ahead of time. And you have a strong pull towards preferred conclusions depending on who you are, depending on if, for example, you're ultimately valuing, reducing the spread of a disease at all costs versus, the educational value of kids actually being together physically in school. Okay, so what I would say is that when you're thinking about these this question, distinguishing scientific facts from political opinions, scientific facts are coming from this upper right-hand corner. And so this is really the realm of the scientific method, right? Where you ask a question, you form a hypothesis, you make a prediction for that hypothesis, you conduct an experiment that's going to test that prediction, you analyze the results. This is an iterative process. Eventually you come to a conclusion. And this is where science derives its credibility and its kind of privileged place as a knowledge generation system. Where down here, you're bringing in these values. And so these are really political opinions. And this is a quote from a Roger Pielke paper, who is in turn quoting the political scientist Harold Laswell, who says, politics is the process of bargaining, negotiation, and compromise that determines who gets what, when, and how. And it's just important to note that the scientific method is not going to tell us how to determine who gets what, when, and how. What hypothesis test are we going to use to determine, exactly what is fair? And so it's really inappropriate to classify these things down here as science if what people are thinking about is the scientific method applied to that. Okay, so let's think about the conventional chain of claims in climate science and climate policy and use this framework to think about where they are in this spectrum of scientific facts to political opinions. The conventional chain of claims can be articulated with these five. So the first one is the dual observation that atmospheric CO2 is increasing and the Earth is warming. The second claim is the causal claim that the increased CO2 from fossil fuel burning is causing contemporary warming. The third claim is the impacts of increasing CO2 and warming are net negative. The fourth claim is that these net negative impacts are larger than the positive impacts or positive effects of further fossil fueled economic and technological development. And the fifth claim is that we know essentially the optimal rate, if not also the optimal means, of decarbonizing the global energy and agricultural systems, which is kind of what's entailed by a 1.5 degree Celsius temperature limit. So let's just knock these first two out very quickly. So, the first one is quite straightforward to demonstrate with our observational systems and is really beyond any dispute. The second one is a little bit more disputable because we can't directly test it, but we can test it in climate models that are based on physics, and the physics is not legitimately disputed. And so that's why these first two represent the consensus on human-caused climate change. So you often hear the number 97% consensus, or in this case, talk about it 90 to 100% consensus of publishing climate scientists basically agree with these two. And so I'll admit that, neither one of these is quite as solid as dissolving salt in water lowers its freezing point, but they're still, in my opinion, up here in the upper right corner in quadrant 1. Okay, so moving on to number 3 is where things start to get interesting. So the impacts of increasing CO2 and warming are net negative. So negative meaning bad, which brings about the technical challenge of how you weigh different outcomes in terms of how quote unquote good or bad they are. But also it just generally entails that you're bringing about kind of a value laden or ethical framework into the question. And I think the evidence for this claim has been driven and really underpinned by the specific ethical framework of the United Nations Framework Convention on Climate Change. So the United Nations Framework Convention on Climate Change, was established and put into force long before most of the research on the impacts of increasing CO2 and warming. And the framework is all about preventing dangerous or negative human interference with the climate system. And so I think what that's done to the conventional climate science enterprise is orient the research in a specific direction. And that orientation has been not to ask this question, but to ask this question. So not to ask, what are the full suite of positive and negative, that would be net, impacts associated with increasing CO2 and warming. So it hasn't really been to ask that, it's been to ask this. What are the negative impacts, so exclusively negative, associated with increasing CO2 and warming? Because kind of the goal, the underlying software running in the background is to look for negative or dangerous human interference with the climate system in an effort to prevent that. So we can definitely see this emphasis in the media if we pay attention to climate coverage. So, here's some examples where it seems like, scientists in the media are really kind of bending over backwards to find negative impacts. So, global heating is cutting sleep across the world. Study finds link between hotter weather and lower student test scores. Study finds that hotter weather is causing people to eat more sugar, which has negative health outcomes. Warming is causing more flight turbulence, and it's even causing more harassment and hate speech online. And so you might say, oh, that's just desire for clicks in the media, but the underlying literature maybe isn't biased. But if you look at catalogs of literature, you do find to see this same bias. So this, for example, is, I think, the most complete catalog of the extreme event attribution literature. This is done by Carbon Brief, where they look at different categories. And what this shows is that when researchers are doing extreme event attribution, they've done 3.6 times more studies on heat extremes alone than on all of the winter extremes. Right, so researchers kind of know ahead of time that the heat extreme is probably going to give them a positive result in terms of attributing that to enhanced greenhouse gas concentrations, and looking at cold winter extremes is not. And so that naturally attracts researchers to conducting extreme event attribution studies on heat extremes, because they're looking for negative impacts associated with increasing CO2 and warming, not positive impacts. You might say, well, maybe the underlying literature has this publication bias in it, but the synthesis reports should be able to kind of correct for that in their synthesis of the literature. But when we look at synthesis reports, like represented here by the Summary for Policymakers of the last IPCC report, you find that they don't correct for this, and they actually kind of just double down on it. So this is an example, observed impacts of climate change on human systems. This is one of their main tables in the Summary for Policymakers, where they have impacts on various sectors up here as the columns, and then the rows are different regions. And look at the key over here. You have impacts to human systems. You have a negative, which means increasing adverse or negative impacts. And then you have a plus minus, which means like mixed results. So there's no plus even in the key, because there's no plus in any one of these 132 combinations. And you just have to raise a bit of a skeptical eyebrow that there's really none of the 132 combinations is warming and increased CO2 good. That doesn't seem physically plausible. But if you look at the diagram, it's basically this comes about by construction, where you have, for example, a heat category, heat, malnutrition, and other. But you have no cold category under impacts on health. And cold is, of course, very detrimental to human health. And so reducing the frequency and severity of cold air outbreaks would be beneficial to human health. But it's just not included by construction on the diagram. Instead, you have things like heat negatively affecting mental health. And you can certainly see the negativity bias in the actual text of the IPCC documents as well, where it just kind of looks like they're assembling as much evidence as they can for negative impacts. Here's an example. Another study estimated that the scenic beauty enjoyed by those who visit the vineyards in central Chile will decline by 18 to 28% by 2050. So just, strong focus on anything that could be construed as negative, and not nearly as much research towards things that could be positive from increasing CO2 and warming. So just some examples of areas that get less attention. That, with increased CO2, you have increased photosynthesis efficiency, and so you would potentially have less crop water demand. That's not emphasized as much. You'd have decreased crop losses from frost days and potentially from increased growing degree days. You have a lot of potential benefits from decreased meteorological drought, because overall you have precipitation increasing with warming. You would, of course, have decreased winter hazards and cold hazards and cold deaths, winter deaths. You have decreased floods from spring snowmelt, which is actually a major cause of a lot of floods. You potentially have decreased tropical cyclone frequency, and decreased extratropical cyclone wind strength and extratropical cyclone strength generally. So all these things, get some treatment, but just not nearly as much treatment as things that can be construed as negative. So evaluating this claim overall, this net negative claim, I actually, do think this is probably true. The impacts of increasing CO2 and warming are net negative, but I don't think it's given the rigorous treatment that a lot of people think that it has been given. And so I would put this down here. that it's less testable than these other two and more complicated. But really, what I'm trying to emphasize is that there's a strong pull towards a preferred conclusion within the research community, which kind of undermines its credibility to some degree. Okay, so moving on to claim 4, I get the sense we're kind of moving more towards political opinions. So claim 4 is the net negative impacts that we just talked about in claim 3 are larger than the positive effects of further fossil-fueled economic and technological development. So I'll argue the opposite of this claim for a moment, just to demonstrate that I think that this is far from an established scientific fact and is more in the realm of politics. So if you look at climate sensitive outcomes of society, kind of food, water, and shelter, you'll see that fossil fueled economic and technological development has far outweighed any negative impacts from increasing CO2 and warming. So if you look at food, I don't expect you to be able to read these. I'm using these essentially as icons, but you look at crop yields across all major crops, those have dramatically increased over the past 60 plus years. You look at per capita kilocalories, so calories available per person over all continents, those have increased over the past 60 plus years. You look at death rates from malnutrition over the past 30 years over all major regions, you've seen a dramatic decline in that. You look at water, the share of population using safely managed drinking water across all major regions, that has increased. You look at shelter, so death rates from disasters, that has dramatically declined over the past century plus. And you look at climate sensitive health outcomes like the geographic extent of malaria today is much smaller than it used to be. And even direct temperature impacts, you look at human cold deaths and human heat deaths. If you look at net deaths from both heat and cold, we've seen a decline in deaths, largely because cold deaths are decreasing faster than heat deaths are increasing, and there's basically a 10-to-1 ratio of cold deaths to heat deaths in the current climate, and so that's what you'd expect. But even when you isolate for heat deaths, in the countries that we've looked at this rigorously, like in the United States, we see a decline in heat deaths over time, and that's because fossil-fueled economic and technological development is outpacing the temperature effect on that outcome, on heat deaths. So I think historically there's a lot of good evidence that this is not true. And so then it becomes questionable whether this further fossil fueled economic and technological development, whether that makes it true or false. And so the question is, if all of this is the case, why is number 4 the kind of conventional view of climate science and climate policy and kind of the educated expert class? Well, I think it actually has to do with kind of often unarticulated value disputes or moral themes. So I think the most common moral themes or value disputes that come up in climate science and climate policy are whether you're kind of valuing the intrinsic value of nature versus focusing or centering human welfare in your evaluation. There's also this kind of conflict between the precautionary principle and cost-benefit analysis, where precautionary principle is going to be to naturally emphasize the negative impacts of climate change, where cost-benefit analysis is going to be a more holistic assessment of energy systems and their alternatives. And then another theme that's very common in climate policy and climate debate is, paternalism and coordination versus a more libertarian approach. And so just to give you an example of these themes coming up against each other, I think that we saw this recently in a recent controversy in the United States, where you basically have conventional climate science as represented by the Intergovernmental Panel on Climate Change and undergirded by the United Nations Framework Convention on Climate Change versus a recent Department of Energy report that came out under the Trump administration called A Critical Review of Impacts of Greenhouse Gas Emissions on the US climate. And there's been a lot of argumentation about kind of underlying facts and which, scientific facts to emphasize. But I think really what this fundamental disagreement comes down to between these two documents is different moral frameworks, where the conventional climate science framework much more emphasizes the intrinsic value of nature, the precautionary principle, which are both somewhat intrinsic to the idea of preventing dangerous human interference with the climate system. And the fact that it's a international United Nations governmental body, kind of paternalism and coordination, where the Department of Energy report takes a much more human-centered approach, much more cost-benefit approach in terms of evaluating fossil fuels. And The authors of this report, as well as the energy secretary himself, very much come from kind of a libertarian perspective. And so I think the IPCC doesn't usually make its moral framework explicit, but I think the Department of Energy report was pretty explicit. So in the foreword written by Energy Secretary Chris Wright, he writes things like the rise of human flourishing, right, human-centered welfare, over the past two centuries is worth celebrating. Yet we are told relentlessly that the very energy systems that enable this progress now pose an existential threat. So kind of this cost-benefit idea. And so he says that's why the report was commissioned. And goes on to write, climate change is real and it deserves attention, but it is not the greatest threat facing humanity. That distinction belongs to global energy poverty. And improving the human condition depends on expanding access to reliable, affordable energy. Okay, so I am, actually pretty sympathetic to this view, but I recognize that this view comes about due to a difference in moral framing. And so then, depending on who you are, depending on your kind of personal politics and your ethical framework that you favor, that's going to draw you very strongly to certain preferred conclusions. So I think this number 4 is getting down here in this left corner in quadrant 4. And also, a lot of these claims are not very testable. Okay, so moving on to the last one, claim 5. We know the optimal rate, if not also the means, of decarbonizing the global energy and agricultural systems. And so that would be what's entailed by a 1.5 degree temperature limit. And so I'll just point out that the 1.5 temperature limit requires an extreme rate of emissions reduction. So about 5% reduction in emissions every single year over the remainder of the century until emissions go negative. That's about the same level of emissions reduction that we saw during the COVID pandemic, but compounded every single year. That would require a huge restriction on energy access. And assessing whether or not this is true involves assessing so many trade-offs across disparate sectors. So weighing the interests of different groups and people and species across space and time. And so it's not clear whatsoever that this is the optimal path, over one of these less stringent emissions reduction pathways that entail more warming in the long term. Now, that doesn't stop, the scientific community from publishing on this. So, for example, you will have papers like Paris Agreement passes the cost-benefit test. But I know that you don't have to get this answer. And that the reason I know that is because I've written a paper in this exact same area that basically says Paris Agreement does not pass the cost-benefit test, or at least not this century. And so I know from publishing in this direct subfield that basically this number 5 is down here. It's not very testable at all, and it's highly susceptible to preferred conclusions because the stakes are so high. Okay, so these last two claims I think are very much in the realm of basically political opinions. Because they have to do with who gets what, when, and how. They're heavily value laden. And that wouldn't be so much of a problem, except for the fact that you get this kind of masquerading as science effect. And so just going back to that previous paper that I just mentioned, this really exemplifies that conclusion that, this paper appears to belong to quadrant 1 because it's written in the language of science, right? Stylistically, it's written in formal academic language in third person, which makes it seem like the results are, completely independent of the authors writing the paper, uses equations and numbers, which give it this sense of authority, and published in a scientific journal, which kind of gives the impression that this is more or less true. Science is subject to refinement, but this is basically true. But in reality, this analysis really belongs to quadrant 4. And so what's really going on here is what gets called the fallacy of misplaced concreteness, where basically the equations and numbers that you're using are giving precision, but it's really a false precision. And so the problem is not nearly as concrete as you're making it out to be. And I think this idea is well articulated by the environmental writer David Roberts in this piece in Grist, which is about a concept within here, discount rates. But he says these are social and ethical disputes being waged under the cover of math, as though they are nothing but technical matters to be determined by experts. But social and ethical judgments should be made in an open, transparent way, not buried in models as inscrutable parameters. I mean, we're talking about how much we value our children and grandchildren. Surely that's a matter for democratic discussion and debate. Okay, here. But this is not widely acknowledged or appreciated by the expert class, by public-facing scientists, by fact checkers. So, just an example of when this controversial Department of Energy report came out, there was a flock of fact checkers and of the established scientific consensus type people attacking it. And so, just an example from Carbon Brief, their fact check. One of their conclusions, from their perspective as kind of an official arbiter of facts, is they officially stamp as misleading the claim in this report that excessively aggressive emissions mitigation policies could prove more detrimental than beneficial. So I think that this is absolutely nonsense that a fact check could adjudicate this claim. And because it's coming from a quote unquote fact checking organization, it's a political opinion masquerading as a scientific fact. And so this is just another example that I can place with the examples raised at the beginning that are inappropriately presenting political opinions as scientific facts. So to nail this point home, I'll quote a couple of passages from an article published in the online magazine Unheard by Matthew Crawford, which was called How Science Has Been Corrupted. The pandemic revealed a darkly authoritarian side to science. So this was in the context of COVID, not climate science. But he says two things that I agree with wholeheartedly. One is, increasingly, science is pressed into duty as authority. It is invoked to legitimize the transfer of sovereignty from democratic to technocratic bodies, and as a device for insulating such moves from the realm of political context. And he says, the phrase follow the science has a false ring to it. That's because science doesn't lead anywhere. So he's talking about science, in the form that most of us think of, which is very much, reliant on the scientific method. So it can illuminate various courses of action by quantifying the risks and specifying the trade-offs, but it can't make the necessary choices for us. By pretending otherwise, decision makers can avoid taking responsibility for the choices they make on our behalf. Okay, so where does this leave us? So just to conclude here. Up here in quadrant 1 is the realm of what most people think of when they think of the word science. So where the scientific method basically applies. And so that's the safest place for fact checking, for potential misinformation policing, and for technocratic decision making. But down here is just the realm of debate and op-eds. And in liberal democracies, we have decided this is the place for democratic decision making. So I think fact checkers and misinformation police can be helpful by trying to discern what is in quadrant 1 from what is in quadrant 4 down here. And if they're evaluating claims in quadrant 4, here's what they can do. They can audit facts and figures that underlie conclusions, the things that kind of come from up here that underlie the conclusions, but really should not try to police the broader conclusions or the broader narratives, because that's just not epistemically justified. I think it'd be really valuable to surface underlying reasons why conflicting claims are difficult to adjudicate. So talk about why a claim is not very testable, or why there's a strong pull towards a preferred conclusion, depending on the person or group producing the claim. And ultimately, I think it'd be very useful to elucidate and do not attempt to officially narrow the range of alternatives that are available for decision makers or for society as a whole. And so I think this would help us navigate the space between facts and opinions. Thank you. Okay, in part 2 here, I'm going to ask the question, can prediction markets help improve public knowledge generation and public trust? So my claim is that a lot of the most prominent climate science is down here in this quadrant 4, where it's not very testable and there's a very strong pull towards a preferred conclusion. And this wouldn't necessarily be a huge problem if there were no biases in terms of which conclusions were preferred. Because if the entire universe of preferred conclusions was randomly sampled, but the problem comes about when certain conclusions are preferred much more within the culture of the people generating the research or generating the knowledge. And I think that idea is concisely shown in this recent PNAS paper on scientific censorship by scientists, where they have this diagram where they show the entire universe of evidence in the outer circle and then what's published in the peer-reviewed literature in the inner circle. And so they show, green stars are evidence that some claim X is true, and red stars are evidence that X is not true. So in the entire universe, there's more red stars than green stars. But in the peer-reviewed literature, there's more green stars than red stars, giving the false impression in this case that X is true. So I'm going to provide a bit more evidence that I think that this is a problem in climate science, making climate science down here. So another way to say that is that a lot of prominent climate science suffers from high susceptibility to motivated cognition and low testabilities. So I've written about this a lot, and there are many, dozens of examples I could use, but I'll just use two examples of published studies from the past year. So one is a study published in Environmental Research Climate called Human-Caused Ocean Warming Has Intensified Recent Hurricanes. And so this got wide coverage as exemplified by this headline over here: hurricanes are being supercharged by human-caused ocean warming. And this article was one of many. So if you look at this paper's altmetric score, this was extremely high, so picked up by many news organizations. So 152 news outlets in the top 5% of all research in terms of online attention scored by altmetric, and in the 99th percentile of research of the same age. And also I'll note for this one, this was immediately incorporated into 13 Wikipedia pages. So because generative AI relies a lot on reading Wikipedia, this makes this study kind of more or less synonymous with scientific truth. So the claim made in this study is quite striking. So this is an infographic put out by the authors of the study, Climate Change Fuels Stronger Storms, where they're basically saying that all hurricanes are an entire Saffir-Simpson category stronger than they would have been in a pre-industrial climate. And you think about kind of a basic, test of this claim might be just looking at historical observations of wind speeds of hurricanes, because if this were true, you'd expect wind speeds to be increasing as it gets warmer. So the most conventional measure of hurricane wind speed is the ACE index, accumulated cyclone energy, which is wind speed over the lifetime of hurricanes squared and accumulated. And we have good global coverage of that since 1980. And it's warmed significantly over that time period, but we do not see any trend in accumulated cyclone energy. And if anything, we kind of see a downward trend since the 1990s. And so what's going on here? Well, I've written about this. It's a bit too complicated to go into all the details of the methodology. But essentially what they're doing here is they're isolating only the sea surface temperature impact on hurricanes and ignoring potential countervailing factors that would make the environment more hostile to hurricanes. So ignoring any changes in hurricane frequency and ignoring things like potentially increasing wind shear and decreasing atmospheric humidity, which would both be detrimental to hurricane strength and formation. So you have this situation where kind of all the knobs are turned in the direction of getting the more dramatic result. And so the question then becomes like, is this just kind of an oversight or an error, by the authors, or is this basically a demonstration of motivated cognition at work? And I think there's strong evidence that it's a demonstration of motivated cognition. And so you get some clues by just looking at the paper itself, that the paper talks about the motivation for the study is connecting the dots between, extreme weather events and elevated greenhouse gas concentrations, that looking at these extreme events like hurricanes act as focusing events that draw public attention, create opportunities for public and private discourse around climate and disaster preparedness. And, they're very concerned about influencing public perceptions about climate risk. So that signals a bit that they wanted a certain result. But then you look at the organization that produced this research is Climate Central. And you look at their website, and what's the mission of Climate Central? Well, is motivated by climate scientists' high level of concern about a heating planet. And the aim is to promote action in line with the threat. So explicitly kind of an activist organization. And so you have to ask yourself, is there some susceptibility to motivated cognition? Further, if you look at, the funders of this study, you have three philanthropic environmentalist organizations, all three of which have mission statements basically in line with the results or the conclusions of the study. So just to take one example, the CO2 Foundation, their mission is to communicate about the urgent societal risks from extreme weather, of course, caused by CO2. So the funders also present a pull towards a preferred conclusion. And then after the study's published, I'm an email subscriber to Climate Central. And so I got this email that is about raising money off of the study. The influence our analysis had on media coverage of Hurricane Helene and Milton before they even made landfall gives just a taste of what we can achieve with your support. Okay, so I think that this is a very prominent study, and it's very much in this bottom left corner. So how testable is it? Well, I kind of showed a basic test of just looking at historical observations, but apparently that test was not enough to dissuade peer reviewers from allowing the paper to be published. But if you look, specifically at the methodology is so conditioned that it actually is very difficult to test directly. But more importantly, I'm really trying to show evidence for a very strongly preferred conclusion, which puts it kind of firmly down here. Okay, I'll give one more example of this. This is also from 2025. This is a paper called Impacts of Climate Change on Global Agriculture, Accounting for Adaptation, where the main results of this study is they estimate that global agriculture production declines by 120 kilocalories per person per day per 1 degree Celsius of temperature rise. And so that was covered with headlines like this from CNN. Children born now may live in a world where the US can only produce half as much of its key food crops. And again, this was not a one-off headline. This was a very widely covered paper that got a lot of attention, very prominent. So picked up by, in this case, 160 news organizations, and in terms of online attention, in the top 5% of all research and in the 99th percentile of research of the same age. Okay, you look at this headline. Children born now may live in a world where the US can only produce half as much of its key food crops. So half relative to what? Certainly most people will interpret that as half relative to now. And the text of the paper and graphics of the paper definitely give that impression as well. So this is one of the main figures in the paper. You have yield percentage change starting in 2010 and going to the year 2100. And you have these, negative trends in all of the major crops. But if you remember from part one, I showed this plot, which is change in crop yields from 1961 to 2023, showing many of these same crops and showing that they've increased dramatically over that time period. And there's even an overlapping time period here, post 2010, that would show that these are increasing historically, but somehow in this analysis, it looks like they're decreasing. Okay, so what's going on here? Well, the left side is not actually a real projection relative to the past. What this is a projection relative to an unspecified counterfactual. And so this implicitly does not include technological innovation in agriculture, which is what's driving all of this increase in productivity and is obviously a huge part of predicting what future yields will be. And so my colleague Lauren Tuchiera at the Breakthrough Institute wrote about this and created this graph where you basically take their projections relative to an unspecified counterfactual, and you use the counterfactual of historical increases in yields, which do necessarily incorporate technological innovation. And so here's what their results would look like in that case, where business as usual in this case is just kind of an extrapolation of the previous trend, and you subtract off different levels of productivity due to climate change. So really, in their most severe scenario, we should still expect increases in food productivity over the remainder of the century. And despite the author's choice to kind of display their results this way, this issue was brought up to them directly in the peer review process. So Nature publishes the peer review file. And if you look at the peer review file, one of the reviewers says to the authors, many people will take these projections at face value as your projection of the future. But in the real world, research and development will continue. Even in the most pessimistic scenarios, it is highly unlikely that climate change would result in a net decline in global yields. And the authors of the paper do not dispute this. They say, we thank the referee for pointing out this important interpretive issue. We hope the textual additions noted above address this important concern. So I'm sorry, but this just seems disingenuous to me if you actually read the paper. It does not feel whatsoever like they addressed this concern. And it was, much worse when they're talking to the media. So the authors did not push back whatsoever against this framing. Children born now may live in a world where the US can only produce half as much of its key food crops, where in the text of the article, it explicitly says key crops could plummet 50% by the end of the century. And this will push up prices and make it harder for people to access food, Saul Shang, a co-author of the paper, said. He goes on to say, if the climate warms by 3 degrees, that's basically like everyone on the planet giving up breakfast. Shang, again a co-author, hopes the study will provide more evidence for the urgent need to transform the energy system and the high costs of failing to do so. Okay, so this is just another example of very prominent climate science being highly susceptible to motivated cognition, as kind of expressed there by Saul Shang at the end. and then also having low testability because it's making projections relative to an unspecified counterfactual. So there's no future amount of crop yields that would falsify their projection because their projection could always just be said, well, it's relative to whatever crop yields are. So if they go up by 200%, we're claiming that they would have gone up by even more, without climate change. Okay, so I think that a lot of prominent climate science occupying this bottom left corner of the diagram can undermine public trust in science and in the knowledge generation system. And so I think we've seen that recently, especially post-pandemic. There's been a decrease in trust in science and in institutional science, at least in the United States, and a particular drop in trust in the institutions that produce science, and in particular, universities. Okay, so can prediction markets help with this problem? So basically what we want to do is we want to move claims from the bottom left and up and to the right. And so what prediction markets do is they allow you to bet on the outcome of future events. And to give an idea of the utility of this, I think it's useful to discuss a bet between just two people first. So the most famous bet in the environmental space is the Simon Ehrlich wager. So Paul Ehrlich, who was a Stanford professor, wrote The Population Bomb, with the thesis being essentially that the Earth has finite resources and human population is increasing, so we will inevitably run out of resources and there will be mass starvation and death. And Julian Simon, who was a professor at University of Maryland and University of Illinois and an economist, he wrote The Ultimate Resource, where the ultimate resource was essentially referring to human innovation. And his position was essentially that human innovation and substitution would make it so that we would effectively not run out of resources. And Simon challenged Ehrlich to a bet. And the bet was, will the price of 5 metals, chromium, copper, nickel, tin, and tungsten, increase between September 29th, 1980 and September 29th, 1990, with the idea being that if prices increased, that would signal that we were running out of resources. And if prices decreased, that would mean that innovation and substitution were outpacing resource depletion. And in effect, we were not running out of resources. So all prices did decrease. And so Simon ended up winning that bet. But that's not the point of bringing this up. The point of bringing this up is that what this does is it moves a claim from kind of down here and it moves it up and to the right. So if we think about the vector decomposition of this move, the two components, moving up the vertical axis means that you are emphasizing a conclusion that is accurate, right? So the preferred conclusion has very little to do with the social circles you're in or your career or broader ethical implications. The only preference for the conclusion is that it is accurate. And then critically, on the horizontal axis, you have the fact that the accuracy of the conclusion or the prediction will actually be assessed, right? In order to have a bet, you have to have very precise terms and conditions. And so you're going to assess that accuracy. And so the financial aspect of the bet, and in this case, the reputational aspect, means that if this is going to be assessed, you want to be accurate. So this moves things into what I think is the most powerful and useful kind of evidence in science, and that's accurate predictions made actually on the future rather than trying to predict the past, which is what we often do in science. So that's the utility of a bet between just two people. But what prediction markets do is they essentially scale these betting dynamics, and they add this additional powerful idea, which is that they aggregate and distill the wisdom of the crowd into a single probability or price. And this idea that prediction markets use the wisdom of the crowd has been around for a long time. Prediction markets have actually been around for a long time. And so this was the topic of two popular books in the early 2000s, Infotopia by Cass Sunstein, How Many Minds Produce Knowledge, and The Wisdom of the Crowds by James Surowiecki, Why the Many Are Smarter Than the Few and How Collective Wisdom Shapes Business, Economies, Societies, and Nations. And so the main anecdote for the wisdom of the crowds, which is used in James Surowiecki's book, is the anecdote of Sir Francis Galton. So in 1906, the polymath and statistician Sir Francis Galton attended a fair in Plymouth in the UK. And Galton was a staunch believer in the superiority of certain expert judgment over kind of the stupid masses. And so he was actually interested in showing that the average person was kind of stupid or unskilled. And he came across a contest where 800 villagers were guessing the weight of an ox after it had been slaughtered and dressed. And so he recorded those guesses, and he found that while many individuals were way off, the average or median of all the guesses was essentially exactly correct. And he ended up publishing that in the journal Nature. And the lesson was that just aggregating many independent, diverse estimates can yield a result more accurate than even what the best experts can produce consistently. Okay, so prediction markets have been around for decades, but they're really kind of gaining popularity and steam recently. And especially in the US, they've gained popularity since the 2024 presidential election, where prediction markets were shown to be much more accurate than polls or statistical models in predicting that Donald Trump would win that election over Kamala Harris. But this is kind of just their most recent triumph, and they've been studied for a long time. They've been studied academically. They even have their own journal, the Journal of Prediction Markets. They've been studied in the context directly of climate risks. So here's a paper, Can Expert Prediction Markets Forecast Climate-Related Risks?, where the conclusion is the predictions of the markets were consistent with good reliability, which is a somewhat tepid endorsement, but an endorsement nonetheless. But the point is that prediction markets can provide very valuable information about the future. But I think even more fundamentally, it would change the emphasis of research questions that are asked. So going back to those two examples that I talked about with hurricanes and crop yields, effectively what the research question was in that hurricane study was, historically, how has warm sea surface temperatures influenced the intensity of hurricanes, holding constant hurricane number and not allowing for countervailing factors that make the environment more hostile to hurricanes? Now, I think this research question was useful to the researchers, but not actually very useful to decision makers or to society. A much more useful question, which would be the type of question that would be emphasized in a prediction market, would just be how many major hurricanes will there be in some future year, like say 2030? Okay, much clearer, much more useful. Similarly, on the crop yield paper, the effective question of that paper was, how will climate change affect crop yields relative to an unspecified counterfactual, taking into consideration a narrow definition of adaptation while ignoring future innovation and assuming an implausible emission scenario that combines the least economic growth with the highest emissions? So rather than that being the research question, a prediction market type question would just be, what will crop yields be in 2030? Or more specifically, what will corn yields be in 2030? Much simpler, going to be tested, and much more useful. So an embrace of prediction markets by the scientific enterprise would mean potentially evaluating the accuracy of prediction markets or directly participating in terms of formulating research questions and models that inform these questions. And of course, it's important to note that the prediction markets are not substitutes for more conventional means of addressing these questions. They are supplements. They sit on top of conventional means and aggregate knowledge from widely dispersed sources and distill it into a single probability or price. So ultimately, what I think this emphasis would do is it would reorient attention towards its most useful ends, which is predicting the future. It would make it so incentives are reoriented towards a focus on pure accuracy, and that accuracy will actually be assessed. So bringing falsifiability back into the picture, which is a key principle of science, by specifying very clear terms and conditions. Something else prediction markets do is they select the most accurate forecasters through empirical trial and error, rather than depending on heuristics such as credentials to define who the quote-unquote true experts are. And so that transparency and lack of gatekeeping should go a long way in increasing public trust on predictions about future climate and energy outcomes. Thank you.